A model rocket is launched from a height of 96 feet. This formula describes the rocket's height, h, in feet, t seconds after it was launched. How long will it take the rocket to reach the ground? Well, the height for the ground would mean h is 0. So we'd have 0 equals negative 16t squared plus 80t plus 96. And this is a quadratic equation, so we can solve it by factoring. To factor, we always take the greatest common factor out first. So I'm going to divide out the negative 16. It's going to leave t squared for the first space. Then 80 divided by negative 16 is negative 5t. And 96 divided by negative 16 is a negative 6. Now I can try to factor the trinomial. I know the first terms will be t. I know they'll be opposite signs. And I can try 1 and 6. If that doesn't work, I can try 3 and 2. But I get a positive 1t and negative 6t for a middle term of negative 5t, which does work. Now solving this quadratic equation, I set each of my factors equal to 0. I have a negative 16 equals 0, t plus 1 equals 0, and t minus 6 equals 0. Well, negative 16 never equals 0, so that doesn't give me any solutions. But subtracting 1 from both sides, I get t equals negative 1. Or adding 6 to both sides, I get t equals 6. Since t is the time in seconds before the rocket hits the ground, I know that cannot be negative because it wouldn't take negative seconds to hit the ground if it's starting at a positive height. So it must therefore take 6 seconds for the rocket to reach the ground.